We have been talking about straight lines up to now. Now, let's look at round stuff. We'll start with circles. And here's the rule. If you have a circle, goes all the way around, you must dimension that with a diameter symbol. Never, never, never dimension a circle with an R for radius. There are no exceptions to that. Always with a diameter. Here's a drawing of something that might be a gasket, maybe an exhaust gasket. And notice how they have put diameter dimensions for the things that are circles, the two bolt holes and the big hole in the middle, diameter. And then they have used a radius dimension for the things that are not full circles, so the end of the gasket and the middle of the gasket. So just to repeat, for full circles we always use the diameter dimension and never, never, never use a radius dimension. When you are dimensioning a circle, you can put your dimension on the view where it looks like a circle, and all of these are acceptable. In fact, I think these might be out of an ASME example. So you can have a dimension that goes all the way through the circle. You can have a linear dimension on the outside of the circle, or you can point at it with what is essentially a leader line. Or you can dimension the thing in a side view. If your part is cylindrical, made of a cylinder, you can put the diameter dimension in that view. If you have a section view, you can dimension the holes in the section view. So here is an example of a linear type dimension, dimensioning the diameter of this hole. Here at the top is an example of a leader line dimensioning the hole, and notice that if you do that in a section view, you point at the place where the center line intersects the surface. That's kind of a fine point. You don't see that all that often. Now, if you have a part that is shaped like a cylinder, like this one here, this stepped shaft, it is preferred that you put all of the dimensions on one view, on the side view. And the reason for that is the person making this object can look at the shape and the numbers, and with one glance can grasp what size and shape this part is without having to move their eyes side to side. It's all right here in this view. You can also use just one view of a part that's made of cylinders. And here's an example. I don't know what this part is, but it's made of 3 cylinders. And we can use only one view, and we know that these are cylindrical for 2 reasons. 1, there's a center line going all the way through it, so that tells us, that's cylindrical. 2, each of these dimensions has a diameter symbol in front of it. So the combination of center line plus diameter symbol tells us what shape this part is, even though we're seeing only one view. Here's the one style that you cannot do. You cannot dimension a cylinder using leader lines pointing at the surface, ever. I know there's some hard and fast rules where they say never, 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 but that's the rule. You cannot do this ever. You can put, where are we? You can put dimensions in the side view. You cannot put leader lines in the side view. Now, something to remember, if for some reason you are using a leader line and you're not using a dimension, when you are dimensioning a circle, when you put the leader line on your drawing, if you were to extend that leader line all the way through the circle, it must pass through the center of the circle. It cannot go off to one side. Now, if you're using the AutoCAD diameter dimension command, it will just do this automatically. It forces you to point towards the center of the circle. Where you run into trouble is if you're using a leader and it's not a dimension and you're just making your own. If you wind up off to the side like this, that's not good, and a checker or me will catch it. Now that center line, long dash, short dash, long dash, short dash, is supposed to have a short dash that's 1/8 of an inch long when the drawing is printed, and then the long dash is 1 to 1.5 inches long when printed. When you have things like holes, and you have more than one hole, and they're lined up as these 4 holes are, connect those holes with continuous center lines. And think about, why is that? What could be the reason for that? The reason is that we can never assume anything. Honestly, that's probably one of the most important rules in drafting. Never assume anything. And if you just had these circles by themselves, and you put the 2-inch height on one side, the reader cannot assume that the other circles on the other side are also 2 inches apart. Maybe they are, maybe they're not. Maybe you forgot to dimension them. And likewise, the side to side. If they're not connected with center lines and you put a 2-inch dimension at the top, we cannot assume that the 2 holes on the bottom are also 2 inches apart. Maybe they are, maybe they're not. The only way we know for sure that these holes are both sets are 2 inches apart is by connecting them with center lines. And now you might be thinking another subtle thought. How do we know those center lines are at 90-degree angles? And if you're thinking that thought, I will just tell you that whenever it is we are going to talk about Dimensioning Rules Part 2, when we look at the fundamental rules of dimensioning, we'll see that ASME has a rule which says if it looks like 90, it is 90, and you don't have to put 90-degree dimensions on every darn 90-degree corner. So that's how we know that those center lines are, in fact, 90 degrees. Here are 2 other examples of parts where the holes are connected with continuous center lines. Both of these happen to be metric, don't they? To state the obvious, when you're giving the location of holes, you always dimension to the center of the hole. And I say that just because you occasionally will see a beginning drafter think they should dimension to the edge of the hole. That is never correct. We always dimension to the center of the hole, and that's an example of functional dimensioning again. It matches what the manufacturing staff will be doing. They will be either getting a drill, and maybe in a drill press, or a boring mill, or they will be getting a punch and locating the center of the punch or the center of the drill where you've dimensioned the center of the hole. Professional tip, and there's some words on this slide, but general idea of a professional drawing is try to make things uniform and consistent, whatever that means in your particular drawing. So in this drawing, here's a flat bar with a bunch of holes in it. And this professional tip is saying, well, if you have things with locating dimensions and hole diameters and one thing and another, it's helpful to your reader if you put all of the locating dimensions on one side and all of the size dimensions on the other side. You don't have to do that, but it's going to be a lot easier to read if you do that. And your reader, your machinist, will be grateful. When you are putting dimensions to locate holes, it's best to use what we call baseline dimensioning. So all the locating dimensions coming off one baseline at one edge or the other. And we'll come back later in a few weeks and talk about what that means. The reason is to avoid tolerance stack-up. You can use chain dimensioning if there's some reason why you need to dimension from hole to hole. Occasionally that happens. All right, I think that's it.